This video goes over Module 6 Homework 4, which is solving by the quadratic formula. So our quadratic formula, we have x equals, so it already solves it for us, negative b plus or minus the square root of b squared minus 4ac all over 2a. Yes, you need to know this formula for the test. So in order to solve one of these, we have to solve a quadratic equation in standard form. Remember, our standard form of a quadratic is ax squared plus bx plus c equals 0. So once we see what a, b, and c are, just like in factoring, we can plug it in and simplify the formula, and we're done. So this first example says solve x squared plus 6x plus 25 equals 0. So it is already in standard form for us. So we know it's already ax squared plus bx plus c equals 0. So that tells us our a value is 1, b is 6, and c is 25. So we can use these values to plug in to our quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to plug in b is 6, a is 1, and c is 25. So negative 6 plus or minus the square root of 6 squared minus 4 times a times 1 times 25 all over 2 times 1. So now that we plugged in our a, b, and c values, all we have to do is simplify. So we have negative 6 plus or minus the square root. Underneath the square root, we have that stuff. We can plug that stuff into our calculator exactly like we see it here. We have to use parentheses like they're written here. Excuse me. So 6 squared minus 4 times 1 times 25, exactly like we see it underneath the radical. Pressing enter, we get negative 64 all over 2 times 1, which is 2. So the square root of negative 64. So I know the square root of 64. Let's do a little side note here. We know it's negative 1 times 64. We know the square root of negative 1 is going to be I. We know 64 is 8 times 8. So we have negative 6 plus or minus the square root of negative 64. We know will be 8i all over 2. So because both terms, everything is being divided by 2, we divide each one separately by 2. So negative 6 divided by 2 will give us negative 3. Plus or minus 8i divided by 2 will give us 4i. Negative 3 and 4i are not like terms, so this is our final answer. My math lab sometimes want us to write it as negative 3 plus 4i, comma, negative 3 minus 4i. So fair warning, this is how my math lab might want it. Let's do another example, solving 6x squared minus 2x minus 5 equals 0. So again, it is already in standard form for us. So this tells us a is 6, b is negative 2, and c is negative 5. So we can just plug in our values into our quadratic formula. So we have negative 2 plus or minus the square root of negative 2 squared minus 4 times 6 times negative 5 all over 2 times 6. Simplifying it, negative 2, so the two negatives make a positive. So positive 2 plus or minus the square root. Plugging this into our calculator, we have negative 2 squared minus 4 times 6 times negative 5, exactly like we see it with the parentheses and all underneath the radical. Pressing enter, we get 124 all over 2 times 6, which is 12. So we need to simplify that square root of 124. So I know 124 is 2 times 62, which is 2 times 31. So underneath the radical, we would have 2 times 2 times 31. It's a square root, so it's going to be 2 of a kind. So those two 2's are coming out of the radical, and that 31 is staying underneath the radical. So we have 2 plus or minus 2 square root of 31 all over 12. So one way to think about simplifying this is GCF, just like factoring. So 2 plus or minus 2 square root of 31 all over 12. So 2 plus or minus 2 square root of 31, they both have a 2 in common. So taking that out, we're left over with 1 plus or minus 1 square root of 31 all over 12. I know 12 is 2 times 6, so that way I know those 2's will cancel, and we are left over with our final answer of 1 plus or minus the square root of 31 all over 6. One more way to think about it, if we have 2 over 12 plus or minus 2 square root of 31 over 12. So simplifying each one separately, 2 divided by 12, they both have a 2 in common. I can divide that out. We're left over with 1 over 6. Plus or minus, 2 and 12 are like terms. They're outside of the radical, just numbers. They also have a 2 in common. This one is underneath, this square root of 31 is underneath the radical, so it's not a like term, so it's going to stay the square root of 31. All over 12 divided by 2 is 6. They both have common denominators. We can rewrite it as 1 fraction all over 6, which gives us back to the answer we got over here. 1 plus or minus the square root of 31 all over 6. So different ways to think about simplifying. Next page. So solving 5x squared plus 2 equals 0. So putting this in standard form, which it's already set equal to 0, but we have 5x squared, there's no x term, so plus 0x plus 2 equals 0. That will tell me a is 5, b is 0, and c is positive 2. So plugging this into our quadratic formula, we get negative 0 plus or minus the square root of 0 squared minus 4 times 5 times 2 all over 2 times 5. Negative 0 is just going to be 0 plus or minus the square root. Putting all of this stuff into our calculator exactly like we see it. 0 squared minus 4 times 5 times 2. We get negative 40 all over 2 times 5, which is 10. 0 plus or minus anything. We don't have to write that 0, so we know it's going to be plus or minus the square root of negative 40. So let's try to simplify this. We know it's negative 1 times 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So we know that this negative 1 is going to come out as an I. These two 2's are coming out of the radical. And then the 2 and the 5 are left underneath the radical. So 2 i's coming out of the radical. 2 times 5 is left underneath the radical, which is 10. So plus or minus 2i squared root of 10 all over 10. So notice 2 and 10 are only like terms because this 10 is underneath the radical, so it's not the same thing. I can't mess with those. 2 and 10 both have a 2 in common, so I can factor divide out a 2 from the top and the bottom. That will leave us left over with our final answer of plus or minus 1i square root of 10, so I square root of 10 all over 5. And that will be our final answer. Next example, 5y equals 3y squared minus 8. Trying to solve this, we have to put this in standard form first. So let's move the 5y over. We're going to subtract 5y from both sides. We're left with 0 equals 3y squared minus 5y minus 8. That tells me a is 3, b is negative 5, and c is negative 8. We can plug these values into our quadratic formula now. So we have negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times negative 8 all over 2 times 3. So negative 5 will leave us with positive 5 plus or minus the square root. Plugging this into our calculator exactly like we see it. So in parentheses, negative 5 squared minus 4 times 3 times negative 8 will give us 121 all over 2 times 3, which is 6. So simplifying the square root of 121. The square root of 121 is going to give us 11. 11 times 11. So 5 plus or minus 11 all over 6. 5 and 11 are just numbers, so they're like terms. So I can split this up and say 5 plus 11 over 6 and 5 minus 11 over 6. 5 plus 11 is 16 over 6. They both have a 2 in common, so I can divide out that 2 from the top and the bottom. That will leave us with 8 over 3 as one answer. 5 minus 11 will leave us with negative 6. Negative 6 divided by 6 will be negative 1 as our other answer. So in Math Lab, our answer would be 8 over 3, comma, negative 1. Last example, solving x squared over 3 minus x equals 1/3. Just like we've seen earlier, our first thing is we want to get rid of those fractions to make it a lot easier for us. So in order to get rid of the fractions, we need to multiply everything by the LCD, which in this case is 3, which is the same thing as saying 3 over 1 whenever we multiply these fractions. So multiplying fractions, we're going to multiply straight across. 3 times x squared is 3x squared, over 1 times 3 is 3, minus 3 times x is 3x, equals 3 times 1 is 3, over 1 times 3 is 3. So we distributed the LCD. Now to simplify, 3 divided by 3, those go to 1, cancel each other out. We're left with x squared minus 3x equals 3 divided by 3 is 1 again. So now putting this in standard form, we're going to subtract 1 from both sides. X squared minus 3x minus 1 equals 0. It is finally in standard form for us, so we can now see what a, b, and c are. So we know a is 1, b is negative 3, and c is negative 1. Plugging this into our quadratic formula, we have negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 1 all over 2 times 1. We have negative 3, which will give us positive 3, plus or minus the square root. Plugging in it, whatever's underneath the radical exactly like we see it. So in parentheses, 3 squared minus 4 times 1 times negative 1 will give us 13 all over 2. 13 is prime. It cannot be broken up anymore, so it cannot be simplified. 3 and square root of 13 are not like terms. Nothing can be simplified here. So this will give us our final answer. Remember on my math lab, they may want you to split it up and say 3 plus the square root of 13 over 2, comma 3 minus the square root of 13 over 2, and not use that plus or minus symbol. But either way, for the test, that will work. Those are your final answers. So this is Module 6 Homework 4 notes.